Hello! Today, we are going to focus on CMM LT units. The units are designed for dehydration, filtration, and degassing of transformer oil. The mass production range of LT units comprises the units with the capacity of 400 liters per hour, 600 liters per hour, 1 cubic meter per hour, 2.2 cubic meters per hour, and 4 cubic meters per hour. CMM LT units with the capacity of 6 and 8 cubic meters per hour are in the phase of testing. For processing of oil, the units use the principle of thermal vacuum drying. For visualization, we will consider the design of the units using the example of CMM 2.2 LT and CMM 1 LT machines. So, here we see the unit's inlet and outlet ports equipped with Chemlock quick couplings. As we move along the inlet, there is a ball valve followed by a coarse mesh filter with a mesh size of 200 microns. The filter is capacious, which allows processing a considerable amount of oil before purification is required. Next, behind the filter, there is an electromagnetic valve that opens and closes depending on the oil level in the vacuum chamber. The electromagnetic valve is controlled by a bottom-level sensor located in the vacuum chamber. The electromagnetic valve opens if the oil level is below the sensor. This valve closes if the oil is above the sensor. Thereby, the optimal oil level is maintained in the vacuum chamber. After the electromagnetic valve, the oil enters the heater tank located in the central part of the machine. As you can see, there is no input pump in the unit. The oil is supplied to the unit due to the vacuum created by a vacuum pump. In CMM LT units, the heater tank is combined with the vacuum chamber tank. The oil rises in the heater tank and gains the required temperature, then flows into the vacuum chamber where it is distributed over a set of elements with a developed surface, which makes it possible to intensify the process of removing moisture and gases from the oil. The removed moisture and gases are discharged by a vacuum pump. The vacuum chamber is equipped with sight glasses for visual monitoring of the process. The dehydrated oil is supplied by a gear pump to fine filters, then through a check valve and a ball valve to the unit's outlet. Thus, we have considered the basic principle of the unit's operation. Let's move on to the control system. The front panel contains actuator start buttons, a temperature controller, indicating LEDs, an emergency stop button, a vacuum gauge, a manometer for monitoring the pressure at the unit's outlet. The control system includes a temperature sensor to regulate the heater operation. In addition to the aforementioned bottom-level sensor, the chamber contains a foam sensor, the task of which is to disable the vacuum pump when foam is detected. Another level sensor is located in the trap. It stops operation of the plant in the event that processed oil enters the vacuum system. I would like to point out the output pump manifold. It is equipped with 2 bypass lines. The first one, featuring a safety valve, prevents overpressure buildup inside the unit. The second one, featuring a ball valve, allows you to adjust the capacity of the unit. When opening the valve partially, part of the flow from the unit's outlet is redirected to the inlet. This makes sense when handling the heavily water-cut oil prone to foaming. The advantages of CMM LT units include easy operation and compact dimensions. For example, CMM 1 LT unit with the capacity of 1000 liters per hour can be easily transported in a passenger elevator. In addition, the essential advantage is the ability to handle heavily water-cut oil up to free water content. I guess we have familiarized you with the design of CMM LT units in reasonable detail. I hope the overview has been useful. I look forward to your questions and comments.